Good afternoon, friends. Today we should be discussing about the cooling system of the automobiles, and which is a very important topics. And the first part we should be discussing today. The topic starts with, and the topic has been discussed by myself, Dr. Kushal Bhattacharya, and the cooling system of an automobile. Now you see heat produced by combustion inside a cylinder, heat produced by combustion inside the cylinder. Now there are the total 100% of, if you consider the 100% of heat produced inside a combustion of a cylinder. Now how is it used? Now you see useful work at the crankshaft. You know the useful work we get at the crankshaft. So 25% of the work we get, 25% among the 100% of the heat produced, useful work at the crankshaft is only 25%. Loss to the cylinder walls is 30%, which is a very huge factor. That is the cylinder walls. The loss of heat on the cylinder walls is 30%. Cylinder walls or the cylinders, which are the main powerhouse, because suction, compression, power and exhaust, we know among the four strokes, mainly the combustion, the power stroke, it occurs. All the suction, power, combustion and exhaust, all the four strokes have been taking place in the cylinder. The cylinder is the powerhouse. So main loss of heat to the cylinder walls is 30%. It's not a matter of joke, it's more than the useful work. And the loss of exhaust is also more, that is 35%. That is why the cause of turbocharging or turbocharged engine has been used. So I should not go in details. When the topics will come, I should discuss how the enthalpy of the exhaust gas is used to run the compressor of the engine for turbocharged engine. I should not go details. But the loss of friction, that is the friction between the cylinder, between the piston ring and the cylinder liner or the cylinder walls, is 10%. So total, if you count, it becomes to over 100%. So this is the total. Total work that has been produced by the combustion engine used in these three form. It is utilized in these four ways. Now loss to cylinder walls 30%. Now what has happened? Loss to the cylinder walls is 30%. If this heat is not removed, if the heat is not removed, what happened? What may happen? Preignition of the charge will take place. Preignition of the charge. What is the meaning of preignition? The meaning of preignition is very simple. Is that when you are compressing an engine of an automobile engine, suppose SI engine, when you are compressing it, so at the time of suction, then you're going for the compression. So when at the time of compression, when the gasoline or the fuel reaches to the self ignition temperature, what happens? Spark has been given to the spark plug. So and then the ignition takes place in three stages. That is the hatching, propagation and uncontrolled combustion. So these are the three stages. I'm not going into details right now. So but before it reaches to that, before the spark has been given, what happens? Due to the high temperature in the cylinder walls, so it catches fire. So before the normal frame front, it catches fire, and what happens? That is called preignition. So when ignition is required to occur, it takes place before that time. So it is called the preignition. So the normal ignition and the preignition, two waves are produced and they interact with each other, and what happens? Knocking takes place. These are the causes of knocking. So if the temperature is too high for the engine, then the chances of preignition can take place. Now lubricants, another important problem. If the temperature of the engines are not, if the heat of the cylinder walls are not removed, what happens? Lubricants can burn away. What are the lubricants used? Lubricants are used between the engine, between the piston rings and the cylinder liner or the cylinder walls. If cylinder liner is not used, there is a contact with the cylinder walls. So if the lubricants are burnt out, what happens? Direct metal to metal contact will take place, which will enhance more rise in temperature of the piston, and ultimately the piston will seize and it will come and it will melt and with the cylinder walls. So so this is a very dangerous case, and it will cause the whole, and it will require the whole engine to be replaced, whole engine block to be replaced. The third point is that if the ignition is not controlled, excess heating will also damage the cylinder walls. As I've told, excess heating is not also damage the cylinder walls. That's why cylinder liners are used. Now what happens? That is an effect if the engine is not, if the coolant is not working properly. But if the coolant is working beyond the limits, that is more than what is desired, so what the problems can come? So if it cools if it's cooled more than the requirement, then what will happen? Then thermal efficiency will decrease. That is also not desirable. the vapor of fuel will be less, result in fall of combustion. That is the vapor formation of the fuel, which also depends in temperature, will not be sufficient, will not be the required amount, which is ultimately decrease the combustion efficiency. And the third one is low temperature increases the viscosity of the lubricants, and hence the friction is enhanced. So what happens if the temperature is low? What happens? The viscosity is low, and when the viscosity is low, then the lubricant will not move to the required passages where metal to metal contact is where metal to metal contact takes place. So if the temperature is not high, the what happens? Viscosity will not the viscosity will not decrease, and the mobility of the lubricant will not take place. So if there have to be a maintained temperature of the cooling system, it should not be such that such low that it will cause all the bad effect. It should not be more, so there should be another bad effect. So it have to maintain an optimal level. So that is the most important part of the cooling system of an automobile. Now cooling system, as I divided, it falls under two heads. The first one is the air cooling system, and another one is the water cooling system. Now air cooling system basic principle. The basic principle of air cooling system is that is to have current of air continuously flowing over the heated metal surface where the heat is to be removed. So the air cooling system basic principle is that is to have a current of air continuously flowing over the heated metal surface over where the heat is to be removed. For example, the cylinder surface, where I showed you that the more heat amount of heat is produced, 30% of heat is produced. So that there should be have ample of air flowing continuous of the heater surface where so that to remove the heat. So now the heat dissipated depends on the following factors. First factor is that the surface area of the metal into contact with air. The surface area of the metal into contact with air. That is the surface area of the metal in contact with air. That depends the amount of heat dissipated. Number two, the mass flow rate of air. What is the mass flow rate of air? That it also dissipated. It also affects on the dissipated amount of heat dissipated. Then the temperature difference between the heated surface and air. What is the temperature of the surrounding surface and the heated surface? So if you are working on a very cold system, on a very cold temperature, suppose you are moving, if you are moving within a very cold, if you are moving in a very cold weather, for example in winter system, in a winter season, so the temperature difference is more. If you are moving your car in a very cold weather, for example if you are moving through Dubai or through Rajasthan, so what happens, the temperature difference is very low. So the heat dissipated also depends on, that is the difference between the heat surface and the air, that is the surrounding air, and the conductivity of the metal. So what is the amount of heat conductivity of the metal? So these are the factors on which the heat dissipation depends. A cylinder with casted fin has been shown. On the cylinder walls lies the cylinder fins. For proper air cooling system, the cylinder fins has been shown. How the cylinder fins are attached to the cylinder walls, it has been shown in this figure. The fins are either cast as an integral part of the cylinder, or separate fine barrels are used over the cylinder barrel. Sometimes, particularly in case of aero engines, the fins are machined from the fourth cylinder blanks. The figure shows a cylinder with fins cast over the cylinder barrels. Now, if you talk about the advantage and disadvantage of the air cooling system over the water cooling system, you see that the air cooled engines, the first one is inevitable that the air cooled engines are lighter due to absence of radiator. There is no radiator, due to absence of cooling jacket, and due to absence of coolant. So if these three components are not there, so for that reason the air cooled engines are lighter in comparison to water cooling engines. That is the reason it has been mainly used for two-wheelers. Okay. They can be operated in extreme climates where the water may freeze. Yes, you can take the automobile if it is air cooled to Ladakh where the temperature is minus 2 degrees centigrade, or any very cold areas where the temperature is more than the freezing temperature. Here there is no chance of the water or the coolant to get freeze. So this can be operated in extreme climatic conditions where the water may not freeze. Now the third condition is that the third advantage is that in certain areas scarcity of cooling water, the air cooled engine is advantageous is over there. In certain areas, suppose you are passing through a desert, like you are passing through Dubai, or you can passing through any Rajasthan or any air or any desert areas where water is not so available at your own will. So at that conditions, air cooled engines may be advantageous. The maintenance is easy because the problem of leakage is not there. Now maintenance is easy because the problem of leakage is not there. So as coolant is not there, so there is no issue of leakage. So there is no issue of any any hose pipe to be heated and there is a leakage of water to take place or the coolant to take place. So problem of leakage is not there. There is an advantage. Now air cooled engine gets warmed up earlier than water cooled engines. Now the warm up time for the air cooled engines is much higher than the water cooled engines. Now the disadvantage, if you come to the disadvantages part, what is the disadvantage? It is not easy to maintain even cooling all around the system, all around the cylinder, which causes the main amount, which is the main powerhouse, as I discussed before also. So all throughout the cylinder same cooling is attained is not possible, so distortion of the cylinder can take place. This has been to some very much nullified by the effect of fins, which is used parallel to the cylinder axis, but it increases the overall. But on the other hand, if you use the fins, it will nullify the effect. That is the equal distribution of heat will take place if you use fins parallel to the cylinder surface. But if you use more number of cylinders, it ensures what will happen, the overall length of the engine will increase. If you increase more than one cylinder, if you increase 4 cylinders, 5 cylinders, the overall length of the overall length of the engine will increase. Now number 2, as coolant of the heat transfer is less for air. Now as coefficient of heat transfer is less for air than water, less efficiency is achieved for air cooling system. So as coefficient water coefficient of heat transfer is much higher than that of air. So the efficiency of air cooling system inevitably becomes lower, and the highest useful compression ratio, CR means compression ratio, you have to use less for air cooled engines, because if you use a higher compression ratio, higher amount of heat is produced. So you are getting no options to dissipate the heat. So you are bound to face higher useful compression ratio. The third one, the fan used is very bulky and it consumes a considerable amount of engine power. The fan used is very much bulky and it consumes a huge amount of engine power, that is about 5%. The fourth one is more noisy. Why it's more noisy? As no coolant is not there, so the coolant acts as a sound absorber. So as the coolant is not there, so the engine is noisy. And the fourth point is that the cooling fins around the cylinders also vibrate under certain condition, which actually enhance the noise of the engine. So these are all the disadvantages of air cooled system engines. Now as I discussed, water cooling system, there are two types of water cooling system. First one is the thermo-siphon system, and another one is the pump circulation system. Now thermo-siphon system, now very simple. The thermo-siphon system is a very simple system which is used in many early automobiles up to about 1940. Please remark the word up to about 1940, and is obsolete now. Now it is not utilized in any water cooling system. circulation of water is obtained from different. Now in this procedure, thermosiphon system, circulation of water is obtained from difference in density of hot water and cold, of hot and cold regions of the cooling water. As we know, hot and cold regions of the coolant is different. So based on this, based on this temperature density difference, the thermosiphon system works. Now let's come to the water second part, the pump circulation system. Now pump circulation system, a block diagram has been shown for the pump circulation system. Now you see in pump circulation system there is a unit called radiator, and on the radiator the top portion is called the header tank and the bottom portion is called the collector tank, and it is connected with the engine. Now there is a fan which is operated by a pump, is driven by means of now a fan is there driven by means of a motor, not from the crankshaft, but the pump. This pump is driven by means of a belt from the engine crankshaft. The pump is driven by means of a belt from the engine of a crankshaft. The pump which is shown over here, the pump is driven by means of a belt from the engine crankshaft. Now how does it works? Now first try to understand the cold water with the help of the pump. Flows over here, and as it moves to the engine, its temperature goes up, and it comes if there is no thermostat valve. If suppose for this check we understand, we take that there is no thermostat valve. What is the function of thermostat valve? I am explaining. Suppose there is no thermostat valve, so what happened? After cooling the engine parts, this water will go into the upper part, that is the upper part or the header tank of the radiator, and this hot water will come down to the collector tank, and as it comes down to the collector tank, what happens? Air passes through it and it cools the hot water. So that is the function of the function of a water coolant system. Now what is the purpose of the thermostat valve? Now we know that what is what is the function of a cooling system? It has to maintain an optimum temperature. Its temperature issue, the cooling should be not with a level of cooling should be there. It should not cool beyond that level. If it could beyond that level, what will happen? The problems I have discussed. The engine seize will take place, and if cool above that level, if too much cooling is there, then what are the problems? I have discussed. So thermostat valve does that purpose. What happens when the engine starts? Basically at the beginning the temperature of the engine is not so high. So what happened, as it moves, as the pump sucks the water from the collector tank, it moves through the engine, it passes to the various components of the cylinder and to the various integrated components. What happens is temperature rises and it comes to the thermostat valve. Now a thermostat valve is there of the liquid by that temperature. If the temperature of the liquid does not reach to a certain value, it will not allow the liquid to flow through the hose pipe and reach to the header tank. So what will happen? It will close that temperature can be fixed. It will close the flow of the tank, and what happened? The hot water will again recirculate to the engine, and again its temperature will rise up to it reaches to an optimum level where it is designed to maintain that temperature. Then only this thermostat valve will open and the hot water will come to the header tank. Now this temperature is normally maintained as 80 to 100 degrees centigrade for the optimum operation of an engine. So what happened, whenever at the starting, when the temperature of the engine is not too high, that if that temperature is maintained, when it reach that temperature, what happens? The thermostat valve opens, and then only the water flows and the outer circuit will take place. If the temperature is not happen, if the temperature does not attain at that value, what happens? Local circuit will be operated. That means the pump will be operating, but the water will not be allowed to flow to the header tank, and the water will be again directed to the engine till the temperature rises to 80 to 100 degrees centigrade. If the temperature rises to 80 to 100 degrees centigrade, then the thermostat valve allows the water to move the header tank, and as it moves to the radiator, the fan is there, the fan and the cooling air passes and it cools and maintains this. So by this pump, two operations are done. One is that as the pump is driven by the belt from the engine crankshaft, so depending on the load or depending on the speed of the engine, the pump speed increases. So if the engine is working under a heavy load, or if the engine speed is very high, so the pump will operate more, and what happens, the coolant supply will be more. And when the pump is running with low load or a very normal load, the pump speed will not be that high, and what will happen, the pump will not operate to that speed. So pump, in the other hand, controls the speed of the coolant passes to the engine. So that is the important factor. So this is all about the block diagram of a pump, the block diagram of a pump circulation system. Now, what are the main components of a pump circulatory system are the radiator, another one is the pressure cap, and the expansion reservoir, pressure cap and expansion reservoir. Another one is the thermostat valve. The fourth one is the pump, and the fifth one is the fan. So these are the main components of a cooling system: the radiator, the pressure cap and the expansion reservoir. The third one is the thermostat valve, fourth one is the pump, and the fifth one is the fan. So this is the way in which a pump circulation system has been operated, and this has been operated for major vehicles nowadays.